Welcome to in my channel. Today I am solving more example on transfer function decomposition. This is the example ys by us equal to 2s plus 1 divided by s square plus 2s plus 3. There is a difference here in numerator 2s is present. So this example is different from other, and to solve this type of example we follow the different method. Okay, now at first we split this function into this form. We can write this function in this way. Okay, 1 by s square plus 2s plus 3 plus 2s by s square plus 2s plus 3. Now we deals with the first part, that is ys equal to ys by us equal to 1 by s square plus 2s plus 3. By cross multiplication we get s square plus 2s plus 3 into ys equal to us. By multiplying ys with s square plus 2s plus 3 we get this equation. Taking Laplace inverse of the above equation means this equation, we get second order differential equation, that is d2y by dt square plus 2dy by dt plus 3y equal to u. As same, we let us suppose x1 dot equal to x2, that is first order differential equation dy by dt, and x2 equal to second order differential equation, that is d2y by dt square, and output equation is y equal to x1. Now this equation put in the b, we get x2 dot plus 2x2 plus 3x1 equal to u. Now we transfer this term into this side. Okay, we get x dot 2 equal to minus 3x1 minus 2x2 plus u. Now this is the block diagram of the first part, that is here. Because this is the second order, we get second order differential equation, that's why here two integrating and two summing point are there, and the coefficient of x1 is minus 3, that's why we have written here minus x3 minus 3, and coefficient of x2 is minus 2, that's why we have written here minus x2, and u is input. And this is second order differential equation, this is first order differential equation. Now we deal with the second part, that is now the second part of the transfer function 2s divided by s square plus 2s plus 3 is the twice multiple of first differential of the first part. Okay, the difference is only here 2s is present in numerator. So the block diagram of the equation a will be, means the block diagram of whole function will be like this. Here this part is same as previous, that this part is same as previous, only the adding, we add one summing point and 2 minus 2x2 is incoming to this summing point, because here in the question the output is output is 2s plus 1, that's why here y equal to x1 plus 2x2, because x represent first order differential equation, and we suppose x first order differential is x2. Now we determine the state model from the following equation, that is x1 dot equal to x2, x2 dot equal to minus minus 3x1 minus 2x2 plus u. The output equation will be y equal to x1 plus 2x2. Now we arrange this equation in this form. This is a state equation form, and x represent here x1 dot and x2 dot in vertical column, because x, the function is second order, that means here x1 first order and second order differential equation is present, and here x equal to x1 and x2. Here x1 dot equal to x2 means in this equation x1 is not, the coefficient of x1 and x1 term is vanished, that's why here 0 and 1 is here. We have written here 1 because the coefficient of x2 is 1. And similarly x2 dot equal to minus 3x1 minus 2x2 means coefficient of x1 and x2 is minus 3 and minus 2, that's why we have written here minus 3 and minus 2. And u is only with this equation, that's why here 0 and 1 we have written here, and u. And the output equation is cx plus du. And the output equation is, in previous part, the output equation is y equal to x1 plus 2x2. That's why y equal to in row and x1 and x2 in column. The coefficient of x1 is 1, the coefficient of x2 is 2. That's why we have written here 1 and 2 in rows. Okay, thank you. If this example is helpful for you, and please subscribe and follow.